Download this code from codegive.com, link in the description below. Clean architecture is an architectural pattern that emphasizes separation of concerns, making your code base easier to manage, test, and scale. It organizes the system into layers, each with a distinct responsibility. In a typical clean architecture setup, you might have the following layers. 1. Presentation layer, handles user interface and input. 2. Application layer, contains application-specific logic and orchestrates actions between layers. 3. Domain layer, encapsulates business logic and rules. 4. Infrastructure layer, manages data access, external service calls, etc. In .NET 8, you can implement clean architecture effectively, focusing on best practices for validation. Validation is crucial for ensuring that input data is correct and meets the business rules before processing it. Best practices for validation in clean architecture. 1. Use data transfer objects, DTOs, represent the data structure for requests and responses. This helps in validation and maintaining a clear contract. 2. Leverage Fluent validation. This is a popular library for building strongly typed validation rules. 3. Centralize validation logic. Keep validation logic in the application layer or in a separate validation layer to avoid duplication. 4. Use custom validation attributes. Extend built-in validation attributes for specific needs. 5. Return meaningful error messages. Ensure that validation errors are user-friendly and informative. 6. Perform validation early. Validate inputs in the application layer before passing them to the domain layer. 7. Keep business logic separate from validation logic. Validation should be about checking data integrity, not about applying business rules. 8. Unit test your validation logic. Ensure that your validation rules work as expected. Example implementation. Below is a simple example showcasing how to implement validation in a clean architecture setup using .NET 8 and Fluent validation. Step 1. Create DTOs. Sharp. Public class create user DTO. Public string username get, set. Public string email get, set. Public string password get, set. Step 2. Create validation rules. Sharp. Using Fluent validation. Public class create user DTO validator, abstract validator create user DTO. Public create user DTO validator. Rule for x equals x dot username. Dot not empty, dot with message, username is required. Dot length, 3, 20, dot with message, username must be between 3 and 20 characters. Rule for x equals x dot email. Dot not empty, dot with message, email is required. Dot email address, dot with message, invalid email format. Rule for x equals x dot password. Dot not empty, dot with message, password is required. Dot minimum length, 6, dot with message, password must be at least 6 characters long. Step 3, create application service. Sharp. Using Fluent validation. Using system.threading.tasks. Public class user service. Private read-only I-validator create user DTO underscore validator. Public user service, I-validator create user DTO validator. Underscore validator equals validator. Public async task result create user async, create user DTO user DTO. var validation result equals await underscore validator dot validate async, user DTO. If validation result dot is valid. Return result dot fail, validation result dot errors dot select, e equals e dot error message. / proceed with user creation logic, example hashing password, saving to database. Return result.success. Step 4, configure dependency injection. In your startup.cs or program.cs, configure Fluent validation. Sharp. Using Fluent validation. var builder equals web application.create builder, args. / register validators. Builder.services.add transient I validator create user DTO, create user DTO validator. / register application services. Builder.services.add transient user service. var app equals builder.build. Step 5, create the controller. Sharp. Using Microsoft.ASP.NET Core.MVC. API controller. Root, API/controller. Public class users controller, controller base. Private read-only user service _ user service. Public users controller, user service _ user service equals user service. HTTP post. Public async task I action result create user, from body create user DTO. var result equals await _ user service dot create user async, user DTO. If, result dot is failure. Return bad request, result dot errors. Return OK, user created successfully. Conclusion. By following the best practices outlined above, you can effectively implement validation in a clean architecture setup using .NET 8. This structure ensures that your application is maintainable, testable, and scalable while providing a clear separation of concerns. Use this example as a foundation to build upon and customize according to your specific needs.